Hi, he is Almiray.
Hello, everybody.
And my name is Ixchel Ruiz.
Okay.
You can find us there. If you later on have questions or want to talk about us of this topic of several others that we like to talk about, feel free. We're always looking for people to share knowledge with and to talk about.
Okay, so as you can appreciate, the topic of the session is Go, Java, Go. The abstract was a little bit light, I guess, but let's see some hands. I suppose most of you, if not all, are Java developers.
Java developers.
Are we correct in this assumption? All right.
Yes,
so
perfect.
How many of you actually are using Go already or trying it out?
Oh.
Just a few. Perfect. Okay. So this is the session for you. Okay. This is off. So we are a pair of developers we're Java champions from Mexico. We work for a company in Switzerland. We do a lot of interesting things with open source. And one of the things that we like to do is share our experiences with everybody. So that's why we are here. You are the reason why we're here on stage.
Yes. So we are originally from Mexico. As Andres said, we live in Switzerland. We work for a company called Trivadis. Both of us are Java champions and Groundbreakers ambassadors. You're using the old name.
Yeah, they rebranded the program just like 3 days ago.
Yes. But anyway, we are very active in the community and we like to share knowledge.
Before I move on, does anybody here contribute to open source? Just a few hands. Well, if you have a chance to contribute to open source, this is one of the ways that it can open your eyes to new experiences and to have new skills. We'll talk about that in later, but just so you know, to keep it in mind, all right? Mm-hmm. Okay, so we'll have some numbers. On one side, we have Java that May 23rd, it had the 23rd anniversary this year. And Go is officially 8 years old, November 10, 2009.
Wait a second. I want to contest that number. Actually, it was 2007 when they first started thinking about the language. And I like to make that distinction because at this moment, you have already concurrency, already multi-threading. So it's significant that language was born after this fact. Because you will, and I'm not going to do any spoilers alerts so far, why Go leverage this and why it's so powerful in these situations. So Go, when the three creators of Go actually sit down and start talking about it, they had several principles in mind. They wanted to do something different. And one of the things that they wanted to do was reduce the complexity and the clutter. So one of the things that first get Java developers is the syntax. Sometimes it looks really strange, but we will see examples. Andres will go into that. No more spoilers alert.
Okay. Well, for those of you that have not yet started with Go, I have two links that are very, very useful. Of course, there's golang.org, where you can find all the information about the language. But the first link, you find something kind of like executable documentation. It has links to many of the features and part of the standard library from Go that you can try out how to work with files and streams, and there's a little bit about database I think, and network, of course. And the great thing about these examples is that there is a tiny gopher on the one of the corners. You click on it, and this will open the same code, the same snippet, in like a web console that runs Go in the browser. Of course, this runs actually Go not in the browser itself. It turns it into some call into the server, executes the code, and then gives you back the replies. And this is very easy to test. You don't need to install anything. You can test it outside.
Yes.
But installing Go is also quite simple. Once you have experience with Go, and this is something that you can do just in a couple of hours. It's very easy to get started. You can test out your knowledge with the other link. It's called Koans. Koans, you can find them for many languages. This particular version of the Go Koans gives you some hints and some tricks on how you can make use of these features, but also has, I think it's maybe a branch where you can find all the answers in case that you may be stuck with something. You actually have to change the code and execute it to see if you got the right answer or not. It's quite interesting. Okay, so the point of this talk is to showcase the Go programming language from the point of view of a Java developer. So I'm going to make a few comparisons within Java.
First question of the session, why Go? If I came to you and said, Andres, why should I learn Go? I'm a successful Java developer. I'm super happy. We have an amazing language. We have a very rich JVM. We have a lot of libraries, that, languages that can run on the JVM. Why Go?
The answer will be coming in a couple of slides.
Oh.
Yeah, no spoilers.
Okay.
We'll see in a moment.
I'm going to spoil something. Yes, for crying out loud. How popular has Go become in the last 2 years?
Yeah, Go is going through the roof.
Yes.
It's amazing how much space they have covered in just 8 or 10 years, depending on who you ask. When you compare that to Java, Java took a long time, and well, who remembers applets? I was there with the Dancing Duke. And then we conquered the server, and we tried to conquer mobile, and we failed. Well, guess what? Go is going to make it.
Well, I'm always very skeptical about statistics and polls and everything like that. But sometimes it gives you an idea of how it is outside. And in a recent poll, Go jumped in just the last 2 years from the 65 language to the 17 in adoption in TIBCO. Again, this depends on who is making the poll and who are you polling, but this is showing us a trend.
Who trusts the TIOBI index? Yes, that's what I wanted to see. Don't trust it, it's not really good. But even, it can give you a few ideas of trends, and Go is really up there.
Yes.
But now let's move into this. So let's say here's your typical Hello World Java that we know and love. It's quite verbose. And we have now in Java 11, who's using Java 11 already, or at least testing it out? Who's using it in production? Yeah, that's what I thought. Please try to upgrade as soon as you can, because now we have to upgrade every 6 months if we want to have free updates. Anyway, so the first version to run this code uses the new feature available in Java 11, which is you can launch a Java source file directly from the command line. Now, there's one restriction. There are a few restrictions, but the most important one is that you cannot have more than one source file, and secondly, you cannot have external dependencies. This is something that we hope can be fixed in the future. So one way we launch the source, and the other way is how we typically do it since the first days. We compile the code into into bytecode, and then we run it. So let me show you exactly the same behavior in Go. We have a package definition. We have imports, just like in Java. Opposed to Java, we don't have the default import of, well, in Java we have the default imports of Java lang and all the classes from it. There's no such thing like that in Go. If you need something, you import it explicitly. In this case, the format package will give us access to certain functions, in this case, the printline function. Now, is there something else missing there? Semicolons. No more semicolons. For those of you that, is anybody here familiar with Groovy? Please say so. Yeah, no semicolons for you as well. So yeah, one character less than you have to type for every sentence. So you can run Go from the source. This is the reason why I was showing also in Java 11. You can run Go from the source and it will figure it out. Or you can compile the code. You say Go build, and then you get a native executable. Now, your question of why Go? Well, we can get a native executable out of our source code, and we have cross-platform compilation. I'm using a Mac, but if I wanted to generate a binary for ARM or for another architecture that is not available in this machine, I still can do it. You cannot do that with the other ones. This is very, very important. And also the binary that is generated is the smallest possible binary that you can run. All right? Either way, we failed to mention earlier, but whenever you have a question, please let us know. Okay, so let's see some familiar features. These are the things that we know from Java, and you will find them pretty much exactly the same and unchanged in Go. Handling values. Values could be just strings, numbers, booleans. Numbers could be integers or decimals. So actually what I did is take out the Go version and rewrite it as Java. So this is very, very simple. Let me show you the Go version. It's pretty much the same. The way the behavior that the print line function behaves is a bit different because now I'm passing an additional argument, whereas in Java I was concatenating the values. But if I run the two programs side by side, both of them will generate exactly the same output, just as you are used to. The other thing that we can see in, or that we can do in Java and Go are control structures, so conditionals. So here is a typical example of an if-else in Java. Nothing very surprising, continues to be a statement. Let's see how it looks like in Go. Okay, no semicolons. Is there something else there that is missing?
Parentheses.
There are no parentheses around the conditional. All right? Everything else looks exactly the same. So you see, it's easy to start to do some translation from one to the other. All right. So what's next? Actually, that's all. From this point onward, everything that we're going to see will be different. Some things will be a little bit familiar, but you have to squint your eyes and you see, yeah, it kind of looks like Java, but it's not. But I promise, at least it's not JavaScript. Okay. In Java, we have four ways to define visibility for a class, for a field, or for a method. We have the keywords public, protected, private, and we have the lovely package protected or package private access modifier, which is the absence of a modifier. Who uses that particular visibility modifier? A few? Probably for testing? Yeah, kind of? All right. Well, technically, since Java 9, now we have 5 modifiers because public is not public anymore. Public is only public if it's exported in the module. So bear that in mind. In the case of Go, we don't have any keywords for visibility. We have a naming convention. So this is the first thing that starts to look weird. If a symbol starts with uppercase character, then it's public. If it starts with a lowercase character, it's private. End of story, nothing else. 2 rules that you have to remember, and that's it. So, in Java, we also have type inference. That we started having a little bit of that in Java 7, thanks to the diamond operator, which allows us to skip defining the generic side on the right-hand side of an expression. So we only need to define the generics on the left side. When JDK came, they gave us the var keyword, which will now allow us to skip defining the type on the right side, but it will infer the type from the left side, from the right side here. So who remembers, or who can tell me what type is the variable string? Is it a list of string? Is it a linked list? Is it an array list? Who says it's a list? Oh, no hands. Who says it's an array list? Yeah, exactly. So if you were expecting to send this to a method that takes a list or a linked list, you'll be out of luck because this particular reference happens to be an array list. So whether you want to have the shorthand notation and having a very specific type assigned to that instance is up to you. And next, in Java 11, we got the ability to use the var keyword as part of the arguments in a lambda expression, for the sole reason that if we have the var keyword, we can put annotations on the lambda expression arguments. This is why. So let me show you the type inference in Go. You can define, it's the same thing, you define use a var keyword, give it a name to the variable, and then the value, whatever this thing is. We'll see in a moment what this thing is. Yes, I know, that looks weird. That's what I say, Twilight Zone. Or you can use the short notation, which who remembers Pascal? Yeah, that's exactly, that's the same operator. It's define and assign at the same time, which means this variable type string, or not this variable name string, will be of such type. In this case is known as a slice of a string, and that will be the value. If you try to define a variable using this operator and you don't give it a value, that returns in a compilation error. If you use this operator and use the var keyword before it, it will also be compilation error.
This is something important that I have to mention. Go also brings a different perspective into error handling. They put more, they ask, or well, they will promote that developers think more about what is a failure, how to deal with errors, and how to recover. I cannot say how, because he will accuse me of a spoilers alert, but it's important that you have that in mind. Here, you will have to think differently about error handling.
Okay, we'll see that in a moment. Collections. So we have support for collections. So now the first thing that you see there, that's actually known as a slice. Kind of like collections as a Java list or a Java set. Okay? So we define the type is in a slice of a string. A string is a base type, and we give it the values automatically. Okay, this is missing the semicolon. That's good. We also have maps. The first line is how we allocate an empty map that is going to take a string as a key and an integer as a value. And we can assign values or read values just like we would do with other scripting-like languages. So this is code that you will see in Groovy or Ruby or even Kotlin. It's just exactly the same thing. This is another way that where we are defining and assigning a map automatically. And instead of making it an empty map, we are defining a map that already takes one key and one value. So these two instructions here are exactly the same, or equivalent to the other one. It's just one line of code. All right? So far, so good? All right, you let me know if there are any questions. Now, arrays. Arrays are interesting. They look like slices, but there is one key difference. The size of the array is immutable, and the size of array is part of the type. We can define arrays in two ways. Just like in the past, use the var keyword, give it a name, and a type. Also, what is different here? In Java, we define the type first, and then the name of the variable. In Go, we define the name of the variable first, and then the type. So in this case, the first line says it's going to define an array of integers, of 5 integers only. So you can fit 5 integers, but you cannot reassign later this to an array of 6 or 4 or any number that is not 5. Also, if you have a function that takes an array of integer 5, you cannot pass as an argument any other type of array that is not an array of integer 5. You pass it an array of integer 4, compilation error. So the size of the array is checked at compile time. So that's even better. And you will access arrays just like you do in Java using the right index notation. You can read and you can write exactly the same way. We have functions. The print line function that you saw earlier is attached to the package FMT. Now, functions, like in any other language, they can have 0 to n arguments. You can have as many as you want. You can even have variable arguments. They call it variadic functions. The return type must be defined at the end, not at the beginning. So this starts to look, again, weird. And it follows the symbol naming conventions. So if the name of the function is lowercase, it will be private. If it's uppercase, it will be public. So what is the visibility of the fifth function here? Private. All right. It takes one argument. It's a type int. Just like variables, the arguments, you define first the name and then the type. And notice that the return type of this function is an integer. And we're using a simple if statement here, a conditional. We're not doing a very good job at what happens if I send a negative number there. Just going to return the number. That's not very good. And, well, just call recursion just like that, easily. Just very simple, just like we do in Java. All right? You can have multiple return values. Say any function can return as many values as you want. This is a feature that has been found in other languages. You might have seen this in the past in Ruby or in Groovy. This is a feature that I like a lot. This particular function can return an integer or a string. And the way that you define the return statement is exactly just like that. You can say 0 or any number and then any kind of a string. And you can return any type as you want and as many as you are as needed. We'll come back to the multiple return feature when we handle exceptions or errors. You can have functions as code, just exactly as we have with lambdas and expressions in lambda expressions in Java. You can create new functions on the fly with Go. Whether you call them functions or closures is pretty much the same. So this particular function here, the greeting gen, returns a function that takes a string as an argument and returns a string. And at this point, I must say that some of my colleagues were looking at Go in this way and said, that starts to look very ugly. I have to parse everything in my head. I start with the function definition. OK, that's good. Then I give it a name. I'm still fine. I have no arguments. OK, so far. And then the return time happens to be, again, a function that takes an argument and then returns something. So where does it end? You just have to get used to this. So the whole return type is actually this. Function string that returns a string. So that's what I put in red. That is the whole function that we're going to return. And then invoking this is just calling the greeting gen function that returns the thing in red. And then we invoke it right now. But I could assign this to a variable and then call it later or pass it around to anywhere a function that takes a string that returns a string is needed. Okay? There are no classes in Go. But we have structs. So if you remember your time of writing C code with structs, don't worry, it's not that bad. Okay? There is no equivalent to POJOs in Go. You can use a struct, and what we use is the convention of the keyword type, the name of the type, in this case person, because it's uppercase, is going to be public, and we say a struct, and we define the properties, if you will, of this particular structure. So this is going to have two properties, name and age, and one of them will be string and the other will be integer. You could have floats, or you can have a reference to another struct. So you can create your own domains if you want, just like we do with Java. Right. How do we instantiate? Yes, question over there.
On the structs, does the public-private naming convention for the values inside the struct?
So the question is, what about the convention for the properties? Do they follow the same rules? Public, public or private if it's uppercase and lowercase. Actually, no. As far as I can tell, if the type is public, then you have access to everything. If it's private, it's just only within that particular piece of code. How do we create instances of these structs? Well, there is no new keyword. We just use the type that we define it. So it's right there again. This is a full-fledged example, by the way. And I'm using the assignment operator immediately. So create an instance that takes 2 arguments, just like that. Or we can also have named arguments. That's quite cool. All right. But the code that I just shown has a problem. Can you spot the compile error?
It's going to be a compiler error.
There is I guarantee you there's a compile error there. So let's see that. We got a definition of the package. Good. We have an import statement. Okay. We define a structure using the rules. That is also okay. We define the main entry point, the main function. Okay. And then we define a variable. We don't give it a type, but it's going to be inferred, that is person. And we create an instance of that. Okay. Where's the error? It doesn't use the variable, exactly. So Go is much more stricter than Java. If you do not use the variables that you define, the compiler will say, stop. You probably made a mistake. Either make use of that variable, you're missing at usage, so you have to put it in a function or somewhere else, or this is code that is no longer needed, so remove it. Either way, it will not let you continue. Yes? The same thing with the input. That's another error. Good catch, because I didn't put the print line there. If the import is not used, the compiler will also tell you, hey, you probably don't want to do this. Thank you.
This is a hassle sometimes when you are developing, because it's easy for us to import things, and then we are using it, and then we delete that usage, and then our code no longer compiles because we import something that we are no longer using. So yes, that's one of the complaints that I hear the most, and it's true. While developing is not the most developer-friendly thing to do, but you have to live without.
Yeah, I can guarantee you that for the first few days that you start writing Go code, the fact that you have to remove unused inputs or unused variables is going to get in your nerves.
Yes.
But it is the way. There's no other thing that we have to say about this.
The other thing that also Java developers will notice is that we have a formatted.
Oh, yeah. One thing that I have to say is that part of the build tools that come along with the Go platform, there is a specific tool called Go Format that can be hooked into any editor, any IDE, even VI, because we know VI is the one true editor. What happens is that when you save the file, Go Format will reformat your code. I will make it look exactly in one way. Now, and again, you might like the formatting, or you might not, but we have no choice. And you might be thinking, that's ugly. Why do I have to use this? I want to use spaces. And then somebody else in your team will say, well,
tabs.
I prefer tabs. And no, I prefer to put the braces on the next line. And others say, no, it has to be on the first one. Do we put spaces around the conditions and the parentheses? You see, these discussions are endless. And the Go people decide, we don't want to get into that mess.
The creators actually spent a lot of months, because the 3 creators are really good, but they have very strong opinions. So by the time they were defining the syntax as what should a proper syntax be, they end up with long discussions. And they didn't agree. So what they did agree on is to have a specific format, create this kind of linter, and say, that's it. This is the way. Now,
there is a very good side effect of this. Everybody's Go code looks exactly the same. So there is no discrimination. There has been a boom in adoption by groups that have been previously underrepresented. I cannot stress enough how many women are in the Go environment. Just because when they submit code, there is no gender, there's nothing attached to that code. The code looks exactly the same no matter who wrote it. So if I were a male that I usually will just disrespect someone because, oh, that code looks like girl code, I don't like it, so it's bad. There's no way I can tell this. My girl code looks exactly like your code. So what I'm looking at is if it's the code that actually works. Does it make sense? Does it have the right behavior? I don't care where or who come up with this particular piece of code. I just care if it does their job.
Yes, and on the other side, there are other languages that at the beginning they said no, that we want to allow developers to have the freedom to decide what is the syntax or the format. The format, not the syntax, the format. But now there are more languages that are creating their own linters and
formaters. They're trying to create something like this, exactly. The second thing is that from time to time, from releases from one Go to the next one, there will be a new idiom that will give you better benefits in terms of performance. Now, because everybody's Go code looks exactly the same, you can automate migration from one idiom to the other. So the only thing that you need to do to have the next advantages for the next release is just pass it through the tool. It will migrate your code automatically, recompile, and you're done. Can you do this with Java? There's no way. So many different variations how to write code. You cannot even think of a very simple regular expression to make migrations go easily from one version to the other. But Go can do this thanks to a very and a single and unique syntax for the source. All right. Also, there are no classes, but there are no methods. But we can attach functions to types. So you saw that the definition of the person type was kind of like a Pojo actually, but it didn't have any behavior. So what do we do about behavior? Well, we can, but we had to use this special syntax. So we define a function, and there is an additional element here that tells us what is the type that will own the function. If we do not define a type, like we did in the past with the Fibonacci function, that belongs to the package. But in this case, the printf function will become a method of the person type. And yes, that is an asterisk. Yes, we have pointers, so we have to be careful about that. So once we have defined this, in our function now, in the main function, we create an instance of person and we invoke printf. And because printf is making use of the print line, there is no other problem with the input statement, and it just works. Okay? Now let's talk about loops. How many ways out there in Java to create loops? Let's talk about the while loop. This is perhaps one of the easiest one that we can find. Simply while a condition, and then hopefully this loop will not continue forever. In this case, the condition will be I has to be equals or less than 3. It will print out the numbers from 0, 1, 2, and 3, and then we're done. Now I want to make it special here that in Java, the increment statement that we have here, we could have put it directly in the printout. I decided to put it separated because when I showed you the Go version, Go does not allow you to have the increment operator there as part of the argument. You had to make it two separate statements. But because we have the ability of type inference here, notice that the while loop actually uses the keyword for, and we have again the consistency of no parentheses. And same condition. Yes, question about it.
Does it mean that the iteration variable has scope outside the loop? Declared before?
Yeah, the question is, what about the scope of the iteration variable? For this particular one, the scope is outside of the loop, which is exactly the same that we have in the Java case. Both of them are outside of the loop. But this is not the only type of loop that we can have. So what about for loops? Your typical for loop in Java. You have defining the variable, define the condition, and the increment, right? Let's see that in Go. Define the variable using the assignment operator, define the condition, the increment, and whatever you want to do. So it is pretty much one-to-one mapping from one to the other. So far, so good? this particular variable will be in the scope of the loop. I will not be visible from the outside. All right, so what about infinite loops? Well, we can do while true, so or some condition that evaluates to true, and hopefully we will break out of the loop. Or we can do this, which is very surprising for people that start with Java. When I first saw Java 23 years ago, I didn't like this. Or we can use do while. Okay, so let me show you how you do an infinite loop in Go. That. It's a for loop with no conditional. And hopefully, we put a break statement. Otherwise, this thing will run forever. So you see, the creators of Go, they will give you the same capabilities, but with a little bit different syntax so that it's more consistent. Why should there be more than one way to do loops? There should be only one. Whether you attach conditionals or not, that will change the type of the loop. But the keyword is exactly the same. All right, let's get into much, much weirder territory. Interfaces. Everything in Java extends from the Java lang object. And we have to explicitly implement an interface. And since time immemorial, Java and the interfaces will define behavior. Now, since Java 11, was Java 9, we can have default methods. No, that's what's Java 8. And then since Java, 9, we have private methods in interfaces. So we are getting very close to the concept of traits. There's our stateless traits. But in the case of Go, everything, the base type, if you will, if there is such a thing, is the empty interface that we see right there. Now, the crazy thing is that we can define an interface like the geometry interface here that has two methods or two functions. These two functions take no arguments and return a float type. Then I define two structures. One is the rect structure and the other is the circle structure. We happen to be private because they use lowercase convention. The same thing as the geometry interface. Now, we are only defining two properties, two properties for the rectangle and one property for the circle. Notice what's going to happen next. We define functions attached to the rectangle and attached to the circle. The names and the return times of the functions match the definitions of the geometry interface. So once we have done this, we can create instances of circle and rectangle and pass it to anywhere a geometry will be available. Yes, question over there.
Price like, don't you have to put in a pointer when you create the function?
So the thing is that, do I have to use a pointer here?
The price like? Yeah.
You mean this here? You could pass a pointer, or you could pass directly the reference here. You're right, there are two ways to define the type here. This code is taken directly from Go by example, so it should work. But if it doesn't, then here's your opportunity to fix this open source project and send a pull request. Actually, so here now, we have this geometry, this method that takes a geometry, so it could be anything. And prints the object, prints the call to the area, and call to the parent method. So we define two instances, one a rectangle, another circle, and just pass those things as value. So is there anywhere that we say we want the rectangle to implement the geometry interface? No. There is no implements clause like we have in Java. The only thing that we have to do is make sure that if we implement all the functions for that particular interface. It could be the case that there is another interface that defines an area method that returns a float 64. If this is the case, then my rectangle will also implement automatically that interface. This could be good, or this could be bad, depending on how many interfaces are available during the whole compilation session. Now we get into errors. Go doesn't, who likes checked exceptions? Wow.
Nobody likes
this is
that.
what I want to see. Everybody likes to, well, we don't like exceptions, but if we had, we would have to use runtime exceptions, okay? So Go doesn't have exceptions like Java does. It has something called errors. It actually has an interface error. So any type, as long as it implements an error method that returns a message, or that takes a message, it will implement the type error. You can use the multiple return value. I told you that we're going to make use of this feature later to throw errors around. This is another feature that some Java people don't like, because there is no way that we can, there's nothing that we're saying here that we're throwing an error or such type. We're simply saying we either return an integer, this is the success case, or we return an error. We see what this thing is. So if the argument is 42, then we don't know the answer to life and universe and everything. So we return -1, signaling that that is not the correct type, that's not the correct value we want. But also we create a new error. Now, given the knowledge that you have already, this is very likely a package. So what is this? That is a function that is public because it uses the, it's a capitalized letter. And given that it's a function, it can take as many arguments you want. This will create an instance of something that is an error. But if it's not, if this is correct, then we just return the argument +3, whatever that it is, and we return no error. We use nil for the error. Now, when we invoke this method, this function f1, we can define it so that it can take one type or the other. And we will have to check if the error is not nil, then we got an exception. So now you can think, how do we chain exceptions? So we are very used to Java to change that we have an exception and then pass it around, and we have this huge stack trace. In the case of Go, we have the choice that we catch an error and we have the decision. Do we bubble it up or we stop here? And the way that we bubble it up is doing exactly that. Return it and keep returning until somebody handles the error. Okay, so they have a couple of gotchas and we're almost out of time. This is a really nice feature that I like that I found in the Groovy codebase as well. You can clone a type. So when defining this thing, we're saying foo behaves like an int, but it's not an int. So it has all the properties of int, but if you see an int as an argument, you cannot send a foo. But if we do type aliases like bar equals int, then this makes bar identical to int. It not only has the behavior of an int, but wherever you see an int, you can fit a bar and vice versa. This syntax came in Go 1.9. We're currently in 1.11. Okay, so why are we going to use this? Finally. Well, if we run Java using Java 11 or compile, we can get some numbers like this. This is just to give you an idea. Nothing surprising. If we run Go, then we get these numbers. Now, let's look at comparison table. If we just run the source, Go is 65% times faster. But in terms of system, it's a little bit slower. In terms of compiling and then running, there is no question. Go is way, way faster. So if you like to write microservices with Go, because you are very constrained about the time that it takes for loading and executing and the size that it requires for the binary, Go is the answer.
Remember that we are very picky about imports, and we only compile to the minimum amount of code that we have. So think that. If you're using cloud, you are sending your software into cloud as a microservice, then you have something that is really fast at startup time, and it's only using the minimum amount of a space. So that's why there's a lot of companies outside that are going towards Go.
Yeah, they're giving
For
it a try.
example, you are I can guarantee that you are using Go on your daily lives. Because, for example, Docker and Kubernetes are using Go. Well, the Docker is written in Go.
Who came here to the conference using Uber?
Uber. Uber is also using.
Who uses Uber?
Uber.
Half of you. Did you know that you're using Go code? Because Uber is running Go. Who is staying here using an Airbnb? Guess what? That reservation you made is Go. And so many other things that we have no idea they have switched to Go. But we're almost out of time. And there's another reason why.
Oh, yes.
And any of you here still using REST APIs? Kind of. And would you like to have bidirectional streaming from client to server and vice versa at the same time? Yeah? It's kind of hard to do it with what we currently have with REST, but gRPC gives you these capabilities on top of HTTP2 as well. So it uses the binary protocol. Now, gRPC was created by Google some years ago. It gives you this capability to do streaming from server to client, from client to server, and at the same time, it runs on Java, it runs on Python, and Go, and C++, and JavaScript, and so many things. But I said JavaScript, it does not run on the browser. It runs on the server using Node. What runs better on the browser is WebAssembly. It's a different way for you to think of WebAssembly as bytecode for the web. And you can compile many languages to WebAssembly. And yes, Go is one of them. So if you want to have, or you need to have a gRPC client on the browser talking to an existing gRPC server with Go or Java, it doesn't matter what it is, then you use Go and WebAssembly, and this is how you can create a full-fledged multi-streaming bidirectional client on the browser. It's very tiny. So we're definitely out of time. Everything that we saw today is open source. You can contribute to open source very, very easily. If you find a problem in an open source project, in a dependency that you're consuming in your daily lives, please file a ticket. That's as much as you can do. If you want, you can supply a test case, or you can even supply a patch. But at the very least, create a ticket. Most of the information that we saw today and other topics get discussed on this URL. The first one is a newsletter in English. The other is a newsletter, the same content in Spanish. And if you care about to hear more about these things, please subscribe or ping us on Twitter. We'll be very happy to have your feedback. Hopefully, some of you are feeling like this after this session and want to give Go a try. We can certainly recommend it very highly. At the very least, if you are not able to use this in production, it will force you to think and reason about a problem in a different way, and then will you approach your Java source code in a different way.
So for me, it's just keep that in mind. It's really popular, it's really powerful, it's fast, it has a very small footprint. It will challenge you to think about error handling in a different way, because we don't have exceptions, we don't have assertions, we don't have generics. On the other side, we can use Unicode identifiers, but don't go too crazy on that direction. And as Andret mentioned, it compiles ahead of time, so we can generate JavaScript code or WebAssembly. So I think it's a really powerful tool for you to learn.
So thank you very much for your time. Don't forget to vote outside. Very cool JavaFX applications. And if you have any questions, well, we will still be here around. Thank you.
Thank you.